Hi, welcome. I know it's late, it's 5 in the afternoon, you had a long day. Do you still have some energy? Yes, oh wow. Usually it's like, yeah, well, get away, we want some beers. But I know I'm in the way of beers, soft drinks and whatever, but um, I think it's going to be interesting for you. I will share a lot of code, um, but don't be scared, the code is available online as well. This is not what we want to see if you visit the website. I don't know if you know what it is. I saw people staring at it for minutes. You are aware that it's a loop, right? I start over at one point. Now, this is called the dinosaur. It's in Google Chrome, and if you don't have a good connection, you can play around with the dinosaur. It's fun, but it's not what you want to show to your users, your website users. This talk is called Offline First. But before we start there, as mentioned, my name is Rowdy. I was born and raised in Gouda in the Netherlands, from the cheese and the stroopwafels, the candles and whatever. And nowadays I'm a front-end focused senior developer engineer with special attention for accessibility. I can add a few more lines probably before I fall off the stage. And I built my first website back in 1996. Yes, I've been around a little bit longer than most of us, I think. Before we start talking about offline first, let's talk about progressive web apps, because that's the basis of the things I show in the talk. And you might wonder, what is a progressive web app? You might have seen this logo, and these are the features that come with a progressive web app. They are linkable. They're just plain URLs. It's not an app on your phone. It's a proper website or web application. They have to be secure, running in HTTPS. Well, I think I said it 2-3 years ago already. Any website should run on HTTPS, right? It's discoverable. Well, it's just a website, or it's just an URL on the web, so search engines can discover and index it. They're responsive. Well, any website nowadays, I hope. The thing is, they are also progressively enhanced. So you make sure it still works on all browsers. Fortunately, we don't have to look at the whole IE anymore since last year. But you make sure it still works on basic browsers and add some extra stuff to make it work on the most modern browsers. You could let them act like an app. You can install them on your home screen on your phone, for instance. You can even use push notifications if you really, really want. But the most important thing is they can work network independent. They can work offline. And that's the last part I'm going to focus on. You've probably seen this website. Yes? But what happens if I'm not on? I visit this page now, but what happens if I go offline? Let's see what happens. Still looks nice, great. Let's open the DevTools. I can also, of course, get off the Wi-Fi, but this is an easier way. Go to the DevTools servers workers, and I hit on offline, and I hit enter, or refresh the page. And then there's the dinosaur again. That's not the experience. It's fun to play and maybe get the new record. Yes, I do. But it's not what we want to share with our users. So let's fix this. I've split it up in separate parts, building on the previous part, on and on and on. So there is starter code. You can see a GitHub URL. Every part is in a different branch. So if you want to follow along, well, not now, but say at home, you can see what happens in every step. It starts really easy. I've set up a simple project with some images and some HTML files and some styling as well. The most important thing is that I have installed an extension called HTTP Server. This is in VS Code, because to be able to work with the service workers we're going to use, you need to run a local server. You cannot say, well, just open this index HTML in a browser. So that's the only thing you need to be aware of. This is an example of a page. It's just text. It has a reference to a style sheet for some styling, and it has some links to other pages. And it looks a little bit like this. So we have a home page, and we have links to the different movies that's been there. If you click through, you get an image and the whole plot. If you haven't seen the movies, don't read it. But some of them are really old, so you might have seen them already. So that's just the basic website. The power comes with service workers, because with service workers we can do special things. If you haven't heard about service workers, let me explain a little bit what it is. It is just a JavaScript file, almost like any other JavaScript file, except it runs in the background. It doesn't run next to your website, blocking stuff from other scripts you're running. No, it runs in a separate thread, so it's isolated. What also means that it's only scoped to that website. That's a good thing. You don't want to have JavaScript code running for website A to be able to do stuff when you're visiting website B. And also they cannot modify the page. They don't have access to that page, to that document object model. And one thing to keep in mind, they're always working asynchronous, so you have to use promises or say async await. And they are event driven. They listen to things that are happening while you're loading the page. To visualize it a little bit, maybe that's the browser. In the middle we have the service worker, and there we have the server and some JavaScript. That doesn't really matter at that point. What the power of a service worker simply said is, well, the browser will request something from the server, but it will go through the service worker. And at that point, the service worker has all the power to do whatever it wants. It can just say, well, thank you for this request, I'm ignoring it, or I'm sending you this response. Or what it will do by default, if you don't do anything, it will set it through to the server. The server will respond to the service worker, not directly to the browser. And the service worker will make sure that the browser gets the end result of what's sent from the server. But it can still manipulate anything that happens in between. Let's set up a service worker. This, I called it sw.js. This is a JavaScript file with two event listeners. It listens to the install event of the service worker, and it listens to the activate event. And it doesn't do really much except writing something to the console that we see something happened. We also create an app.js, or whatever you want to call it, a JavaScript file that's next to your website, that's being called from your website, because you need to make sure that that service worker is loaded. So we first check if the service worker is available. We probably don't have to do that anymore because IE is gone, and pretty much every modern browser supports service workers, but in this case we still have the if statement at first. And then we look and we listen to the load event. So as soon as the page is fully loaded, we will register that service worker file that I mentioned before. And again, we say, well, it's registered now. And if something fails, we write it to the console as well. We don't do anything yet, but it's just making sure that the service worker is activated. And of course, we need to include the script that is triggering the service worker. Not the service worker itself, but this script. And simply, it's something like this. If you refresh the page, you can see now at service workers, there's one activated, and you can see the log lines here. Well, nice, we have a service worker, but it doesn't do anything. So, here is the sheet with the support. Opera Mini and IE don't support it, but that's fine. What we do want to do is make sure that we already cache some files on the user's device for the second time or the third or the fourth time they visit our page. Because there are a lot of files like images or some styling that needs to be there every time. And we don't want to have the user the second time they visit your website have to make the trip to the cell tower, and the cell tower to the server, server back to the browser, because we can already make sure it's in the browser itself. A good practice is to give your caches, in this case a static cache, a version number. Please don't use a number directly. I've been there and it's troubles. So make sure it has a something like static v1 or something. And I now have a list with files I want to make sure that are cached the first time you get on the website. So in this case, the homepage, the index.html, a fav icon, some styling, a font, and an image, and my JavaScript. And in that same service worker file, we already had the install event, if you remember. What we can do there is we open the caches. In this case, we open the static cache, and we just add all the files that are in that array. And now the service worker knows, well, if I get that data from the server, I'm going to store it locally. We do the self-skip waiting because otherwise a user interaction is needed. The user needs to come back for a second time, and we don't want to do that. We want to have it immediately. If we go back to the app.js, we already had this. We registered, and then we write a console. There are two things we can do. What I did here is I'm listening to the unupdate found. And that's a message you get from the service worker that there's a new version of the service worker found. And in this case, I'm just showing a confirm dialog saying, well, hey, we have a new version of our website. Do you want to update it or not? You give the user the power to make sure that it happens. And what it will do is it will reload the page, essentially, to make sure that the service worker is activated. You can also skip this and immediately refresh the page, but I'm not sure if that's a nice way for the user to see a flashing page and like what's going on. But you be the judge of that. This is the part that's essential that you're going to see here. So I clear out the console, I refresh, and there's the dialog. And if I hit OK, you can see a little flash probably. Yeah, it's too fast. But we now have static v1 in our cache storage here with all the files that were in the array. Now that's a good thing. But it's there. We don't do anything with it. So that's not what we admire here. So what we want to do is the cache that we stored, we want to fetch that and use it. Because you can see here, if I refresh the page, although the files are in the cache, you still see that there is data transported over the line from the server to the browser. So what we're going to do in the service worker itself, we're going to introduce a new event called fetch. As soon as the browser wants to get some data from the server, this event will be triggered automatically. And what we do here is we try to match the URL that's requested from the server, match it with files that are in our cache already. And if it's there, so the if response, then we just return it from the cache, and otherwise we still fetch it from the server. So if we look at the service worker and we refresh, we will get a new service worker again because I added something to that file. We say, okay, let's refresh that. And now you can see in the network, every file that's shown on this page is coming from the service worker. And you probably didn't see it, but if you compare this, a load time of 35 milliseconds, that's already really fast, but that's because the server is running locally on this MacBook, so it's fast already. But from the service worker, it's only 18 milliseconds. Imagine you have a really crappy connection, maybe on the road somewhere, then that 35 milliseconds is not realistic to get. So from the service worker, we'll be many, many times faster. More or less like this. And this gives me time to take a sip. Well, we don't want the users to scream, but we want to have that feeling of speed, right? That's nice. That first page is cached now and it's served from the service worker. But what if we go to a page that's not cached? Let's say we go to a page, maybe the first one. Okay, I'm online, it's fine. I get the image, I get the text. But what happens if we go offline and go to a different link here? I refresh it, I still get the home page from the service worker, you can see, but I go to a different page. It tries to load it from the service worker, it doesn't exist, it tries to go to the network, but yeah, we're offline, so we don't even get the dinosaur. It's like, sorry. So that's not a good experience. What we can do, in this case, is create a page called offline.html. It's a plain HTML page just saying, well, sorry, this page isn't there yet. Maybe you can watch or visit one of our other pages. To do this, we change the version number of a static cache from v1 to v2. Because we want to make sure that the files are being saved, because we are adding offline.html. If you don't change the version number, you will get problems getting that file saved to the cache. So good practice is always, if you add more files to this list, make sure you update the version number. Again, update the version number. And what we now do is, let me go one back. We fetch it. If it's not in the cache, we fetch it. That's the last line there. But we add something. We add a catch. If something goes wrong, if the file's not there, we will open our static cache and return the offline HTML. So the user doesn't get a blank screen or a screen saying, well, you're offline. They still get a page. But we don't want to serve this HTML file if a JavaScript file is missing or an image or whatever. So we have to make sure that in the headers we need to check whether the request was for a HTML file. And if we do that, again, we need to refresh and accept the new service worker. You can see we now have v1 and v2. That's a problem. We'll come to that. But in the v2, we have offline HTML. And if I go now offline and go to a page that isn't cached, well, you can see, sorry, the park is closed, but it's better than just using a black screen here. Try one of our other pages. Well, we only have the home page by now, but we're going to make sure there's more for the user. Because we gave a static list of files. That was our home page. That should always be there. But we can also introduce dynamic cache, meaning that any page you visit, we make sure it's saved to the cache, and next time you visit that page, it's instantly there from the service worker. And if you have offline, you still can visit that page. I give this also a version number, dynamic v1 in this case. And in between all this code we already have in a service worker, between the fetch and the catch, we make sure that anything that is fetched from the server is now put in the dynamic cache. So we open the cache, the dynamic cache, and we put a clone of the response of that browser in there. Or, sorry, a clone of that response of the server in that dynamic cache. Important to mention that you have to make a clone of that reply, because otherwise you cannot serve it back to the browser anymore. So let's see what happens. Refresh again. If you're developing with service workers, you're gonna do this a lot. this is not what your users get, but when you're doing it, yeah, that's a downside of it. But you can now see I went to a different page and I have a dynamic v1 now with those two files, the HTML and the JPEG that's on the page. If I do it again on another page, you can see we get the other one as well. So if we go to server workers and go offline again, I can now go, I refresh the home page, that still works. The first page works, this is from the dynamic cache. And also this page works because we already have it, but this one will fail because the user hasn't visited that page yet. And as I mentioned, this could be a problem. We have a v1 and a v2 here. You as a developer have no idea from which static cache the file will be retrieved. So you could still serve the user with a very old JavaScript file, for instance, or an old image. So we need to clean this up. To clean this up, we also now, of course, have the dynamic v1. You could have a dynamic v2 as well. If you want to make sure that if you change a lot on your website, you want to make sure that people get the latest ones, you could clear the old dynamic cache as well. To do that, we hook into the activate event. And as you saw in the beginning, we just console log a statement there. We're going to add some stuff here. We go through all the caches. So we get all with the caches.keys, we get all the keys, all the, say, IDs, the version numbers of all the caches we have, the static ones and the dynamic ones. And we go over them and just check whether the key we're getting is the same as the static cache version number or the dynamic cache version number that we already have in this file that we want to make sure the users use the latest versions. If they're different, we just say, well, just drop this cache, just delete it. So refresh again, and you can probably imagine what to do. Click OK here. And now you see it has static v2 and dynamic v1. Static v1 is gone. So that's a good thing. We clean up after ourselves as well, because having many caches also means you're using the user's storage on their device. And it can grow extensive if you have a lot of files. All right, that's all fine. Now the user has to have visit the page to make sure it's in our cache. So the next time they come on the page, it will be instantly there. But what about pages they haven't visited yet? You want to give them the same experience. So what we can do is called prefetch. And this is the definition of prefetching. Basically says, well, we are going to request the data already from the server, maybe not even knowing that the user will get there, but when the user will go to that URL, the data is already there, so it's instantly there. All right, to do this, this is the home page, but it doesn't really matter what page it is. On the home page, what you could do is add a link with an attribute of prefetch, and then add the href there. So you could write some JavaScript saying, well, I'm gonna create a method called add_prefetch link that's been fed a URL, and I just add in the header, I'm adding the prefetch for every single one of the URLs I have there. So in this case, I'm query selecting all the links that are on the page, and I'm adding them all to the prefetch, and you get something like this. It works. Well, it works except on one of the two mobile devices. So that's, and it's also, it could be a very long list in the end. So that's not really the solution we want. Let's do it a little bit more optimized. We still will search for all the links on the page, but we will then fetch it immediately from the server with fetch. Well, all the links on the page, does that make sense? So you have a really long page with a lot of links in it. The user only scrolls, I don't know, a third of your page. Then you're prefetching maybe 30 documents already. It's not that nice, probably. So what we could do is add data attributes to them to make sure that we only fetch the ones we really want. And this solution also fetches all the links to social media, for instance. If you have a link to Twitter, your Twitter account, or Facebook, or whatever, it will fetch this, but it will never be served to the user. So it doesn't make sense to fetch external URLs. So if we use something that's called a data attribute, maybe I can put data skip prefetch on it, on maybe a Facebook link or something. And then we rewrite it a little bit, saying, well, every link that doesn't have that data skip prefetch attribute, we will still fetch. And when we fetch it, it's automatically saved in the dynamic cache. We don't have to do anything extra for that. Okay, that's better, but as I mentioned, if you have a very long page with a lot of links, does it really make sense to prefetch them all? We can use something that's called the Intersection Observer API. And the Intersection Observer API makes it possible to see where the user is at that point. Where are they on your page? And we can make use of that. This is how you instantiate an intersection observer. And as soon as the intersection ratio equals 1, that means in this case, the link is in view of the user. So it has scrolled to that point. So what we again do is we collect all the links on the page that don't have that attribute of data skip prefetch, and we let the intersection observer observe these links. It will just stay in the background saying, well, is this one in view yet? Yes, and now I'm going to fetch it. However, the thing is, we want to make a list of files that we have cached, of URLs that we have cached. That's saved in the dynamic cache, but the only JavaScript that has access to the caches is the service worker. And you want to show that data on your website, but the website JavaScript doesn't have access to the things the service worker has. So we need to do something in between there. So what we're using is local storage. We can save data next to the cache in a different part of the storage, saying, well, you know, I'm going to save the href, so the link that's going to be fetched, but also saving the text that was on the link. So we have a key value pair of, say, the link text and the URL itself. And we only do that if it's not fetched already, if it's not in the local storage saved already. All right, I'm going to add something, I'm going to change something, so I up the version. Can't say it enough, because we changed the service worker file. If I now refresh, I get the OK again. And we're going to scroll a little bit. And you can see, well, okay, this one we already know, but hey, look, Jurassic Park 3 from 2001 is now in our cache. And Jurassic World from 2015 is now cached. So if the user will now click on one of those links, it will be there. And here you can see the key value pairs I said. So we have the URL with the text that's belonging to it. If a user now will click on one of those links, clicks on one of those links, it will be served the URL that's fetched. One thing though, it will not serve the image that's on that page. It only fetches the HTML. So it's not a full experience the user get when they are offline, but I hope your applications or websites are built in a way that the most important information is available with HTML and not depending on other, on images, for instance. That's all fine, but what if you are on a slow connection? Maybe the user is also doing something else on this device. We don't really want to say, well, you're on a very slow connection. Let's fetch all those pages already. So there's something called the effective type, network information.effective type. It's a property that's not on every browser available. It's not available on Safari, for instance, but it's available on Android devices. So you could rewrite your code. I didn't do it, but you could rewrite your code saying, well, if it's underneath, I don't know, 3G, I'm not prefetching, for instance. Just to be considerate to your user. And also, this is also an Android thing for now, is you can set in your Android device, you can say, well, I want to use the save data option. Maybe you are on a holiday abroad where you buy an internet bundle for way too much money. But in that case, you don't want a website just to download all kinds of stuff, or maybe even a video of 25 megabytes, for instance. So if a user sets this save data, we can also listen to that and also can say, well, okay, if the user has enabled save data, we are not going to prefetch stuff because it will hurt the user. Also, as I said, this is supported on Android and not on iOS yet, I hope to say, but I'm not sure if it ever comes to iOS. All right, we're almost there. We now cache static data, we have dynamic data, we have an offline page, we prefetch stuff. But if you go off, if you're offline and you go to a page that's not cached yet, you still get that the Jurassic Park is closed. Just find one of our other pages. And then you go to the home page and then you click another link. Ah, sorry, it's not cached yet. So let's improve that a little bit. This is what we had. Why don't you try one of our other pages? What if we just add a list of pages on the website that are available offline? We know that because we save them in local storage. We had that key value pair there. So I'm creating a new JavaScript file called offline.js. And I'm adding it to the service worker. So I'm updating the version number again so to make sure that we all get the latest files. And now in the fetch event, I do something extra. First of all, I need to know in my website what version number is available from the dynamic cache. So I just use a Boolean here to say, well, you need to set it to the cache for now. And if it's true, then I will wait till the, I will connect to the client, that's our JavaScript on the front end, and we are posting a message. Because that's the only way a service worker can connect to a JavaScript file that's in your website. We can post messages to the client, and the client in this case is the other JavaScript file. And what we do is we send an action, and in the dynamic we set the version number. And then we say, well, set dynamic version in local storage to false because we only need to do it once with the first time something is fetched. Now, in the app.js, we're going to listen to messages from that service worker. And that's just add event listener to the message. And we have set that action ourselves to set dynamic version in local storage. So if that action is provided by the message, then we will store that version number of dynamic cache in there, because we want to make sure that we are using the correct one. Still here with me? Right, almost there. This is my new offline.js file. And what I'm doing first is I'm retrieving that version of dynamic cache that we were mentioning. Because in a JavaScript file, I cannot directly communicate easily with the service worker, but I do have access to the caches. So now I know in which cache I need to look for the files. So I open that dynamic cache with that version number that's provided by the service worker, and then I just retrieve all the HTML files that are in there, or let's say all the keys that have the extension of HTML. And I saw this afternoon. I made a slight error here because I'm excluding the offline page. But do you know where the offline page is stored? Do you remember? Static one, yeah. So, and we're only looking at the dynamic one. So you don't have to do the extra check whether it's not the offline page, because we want to return a list of available pages. And in this case, if the offline page was in the dynamic, you don't want to say, well, do you want to visit our offline page? I don't really think that's worthwhile. So in this case, we're retrieving all the URLs, all the HTML files, let's say, and we return it to a method called cache list. And what this does is just creating a list of files or URLs essentially. But it needs to do first create an element of li for the list item, create an element for the link, and then add that link to the list item. So you need to do a little extra stuff for it to make sure that you get that nice list item with link. We get the URL out of there and the text we want to show. And in the end, we have a list of available offline files, offline URLs. And that will look like this. So again, new service worker, so refresh. You can see I have the offline.js now in my static v4. This still works. Well, let's go offline. We have some files already in our dynamic cache. So this works. This works. I think we went through the third one again. Here you're missing the image. This is prefetched but without the image. Okay, but it's still usable. But let's go to a page that wasn't cached. It's closed. But now if you scroll a little bit on, you can see, well, you can still visit these pages. We know these one. We have cached these for you. And you can now see in the local storage also the dynamic cache version that we saved there once. So that's a better experience, I would say, for a user, especially if you're maybe in the Netherlands, we have Wi-Fi in the train, but in certain areas in the Netherlands, like it's more like Li-Fi. It's just, you have those arrows, say, well, that sign of a Wi-Fi, but essentially nothing works. So this is a nice solution, I would say, if you still want to continue using that website. And with that, I'm already at the end. I'm not going to pronounce this because I'm going to butcher it. But I do want to say thank you. And if you want to have these slides or go to the GitHub repository, just go to my website, rowdy.code/Jfokus, and you will be redirected to that. And you can go either drink beer, wine, or whatever, or maybe ask some questions if you have some.
Caching is famously one of two hard problems in software development. And you do a lot of logic for handling the caches. Do you get anything for free from the browser, like expiry or anything? Can you use the browser to handle stuff?
The way I use caching now, you're fully responsible of making sure it's still fresh and up to date and you clear the stuff. The other caching in browsers is, say, the default caching. They don't invalidate it either, but it's more like, we don't have enough space anymore, so just drop something that's already there. But in this case, if you do it like this, you're fully responsible of making sure that cache is fresh and cleared if needed.
And what happens if you fill it up, the dynamic cache? Does it get full?
It will drop, eventually it will drop files as well, but you have about 10 megabytes usually per website. That can contain a lot of HTML files. You might not want to cache other big images maybe or something. So what I showed is like you just cache everything to the dynamic, but maybe be a little bit more sensible about it. Not everything needs to be there maybe. Maybe you are changing some files that are a little bit more dynamic. Maybe you insert some JavaScript files or something you don't want to be cached. Well, exclude them. But make sure that the JavaScript files are not really essential to showing something when they are offline, because then it defeats the purpose. Thank you.
This was really helpful, thank you.
Thank you.
Would something like this work with a like a front-end framework like React, Angular, Vue, or one of those where, especially if you're using like the router packages where you have like, you know, you listen to routes and you respond with components and things like that?
It works until you deploy a new version, because probably then there are some hashes in URLs that will change. What I didn't show you here is also you can cache API calls. So if you have an application that also does have some dynamic data, you can still cache that. It's a little bit harder to do that with front-end frameworks, but it can be achieved. But be more sensible of what you want to cache. Maybe it's more beneficial, for instance, to not cache the HTML, but cache images or some other items on that page.
Okay, thank you.
You're welcome. I see everybody, beer, wine, soft drinks, food. Shall we release them?
Sure.
Yeah? Okay, thank you.